Hello friends, in this video we are going to discuss about a numerical on career lifetime. In the given numerical is written as N-type semiconductor silicon sample contain a donor concentration of Nd equals to 10 to the power 10 per centimeter cube, and the minority carrier concentration or minority carrier whole lifetime, it is given as tau p equals to 10 microsecond. So we have to find the lifetime of the majority carrier in terms of 10 to the power 6 second. So we can see from this numerical that lifetime of majority carrier is to be found in terms of lifetime of minority carriers. So we can say that the lifetime of the majority carriers, that is tau majority, and it is an N-type silicon sample. So we can say that the majority carriers will be electron, so tau n0. So tau n0 is the lifetime of the majority carriers in the N-type silicon sample, and we know that tau n0 is denoted by, is as an equation, that is Nd by Ni whole square into tau p0, where tau p0 will be the minority carrier, that is the whole lifetime, and tau p is given by 10 microsecond. Now the doping concentration is given by 10 to the power 18 divided by Ni, and Ni value for the silicon we know that it is 1.5 into 10 to the power 10. So it will be the whole square, and tau p0 is provided as 10 microsecond. From this equation we can say it will be 10 to the power 36 divided by 1.5 whole square into 10 to the power 20 into 10 to the power minus 6, because it is in microsecond. So now it is in second. If we calculate this thing, then we'll find it as 4.44 into 10 to the power 6 second. So the answer will be 4.44, and 10 to the power 6 is already written in the question, so 4.4. So in this way we can calculate the lifetime of the majority carriers in terms of the minority carrier lifetime. Thank you.